Hi everyone, thanks for listening to the highlights of our paper. My name is Amin Fazat and I'll provide you with these highlights. The goal in this work is to utilize synthetic speech for ASR training in new applications where data is sparse or hard to get. To achieve this goal, we applied continual learning with a novel multi-stage training strategy addressing catastrophic forgetting of the model during fine-tuning to new applications. The diagram of our proposed system is illustrated in this figure. The text for the new applications are fed into our multi-context TTS engine to generate synthetic speech. We use an RNN-T model for speech recognition and trained it using a multi-style training with samples from both real and synthetic speech. We have found that through this multi-style training, model learns the mismatch between the real and synthetic data. We have also found that data augmentation is effective to improve the performance. Continual learning with our proposed multi-stage training consists of 4 stages. The purpose of first and second stages are to ramp up the parameters of RNN-T for the new application with samples from both real and synthetic data by freezing the encoder in the first stage. The third and fourth stages are to recover performance degradation on existing application by excluding TTS data in fine-tuning. To ensure that the learned parameters do not deviate too much from the previous stages, when trained with synthetic speech for a new application, an elastic penalty term is introduced to the RNN-T loss functions. Here's a quick look at our results. To evaluate the effectiveness of synthetic data, we first performed the experiments on LibriSpeech dataset, where we used 480 hours of real data and used the text from the rest of the data to generate 1150 hours of synthetic data. We compared this model against a model trained with only 480 hours of real data. We found that simply adding synthetic data relatively reduced ASR word error rate by 12.5%. Then we then expanded a general purpose ASR model for a new application of medication name recognition with no real recording for ASR training. The results for 4 stages of fine-tuning are provided in table 2. As shown in table 2, the final model from stage 4 achieved a slightly better performance on general test set compared to the baseline model, and at the same time, the recognition performance on medication names is more than 65% better than the baseline model. If you are interested in more details, please visit our live session. We look forward to further discuss our paper with you. Thank you.